Hi everyone, my name is Xin Qiu, a researcher at Coordinate AI Labs. Today, I will briefly introduce our recent work published in Europe's 2024. The title of our work is Semantic Density, Uncertainty Quantification for Large Language Models Through Confidence Measurement in Semantic Space. Basically, our work is trying to propose a quantitative indicator that can be used to evaluate the trustworthiness of the responses generated by large language models. Because of the improved capabilities of the large language models, they have been applied more and more often to those safety-critical domains like healthcare or finance. However, existing language models, they only generate responses without any additional indicator for their confidence or trustworthiness. So it is difficult for the users to evaluate how trustworthy is this response. There are several existing solutions to these problems. However, they all have different limitations. The first limitation is that some of the existing solutions, they can only be applied to language classification tasks instead of those free-form generation tasks, which are more commonly seen in nowadays applications. The second limitation is that they are not off-the-shelf, which means that some of the techniques needs to train an additional predictor with additional training costs and additional training data for each particular task. And when a new task comes, this retraining process needs to be performed again. So it may not be feasible for many real-world applications. The third limitation is that most of the existing techniques, they only consider this problem in lexical space. However, we all know that the same semantic meaning can be represented by different phrases or different order of words. So only looking at the information in lexical space may not be sufficient. We also need to consider the information in semantic space. The last limitation of existing work is that some of them are only prompt-wise, which means that the returned confidence or uncertainty metric is only for a particular prompt, regardless of the responses it generated. So our proposed semantic density is trying to resolve all these limitations at once. So the basic idea of semantic density is that it is trying to analyze the output distribution of the language model in semantic space and form a technique similar as the traditional kernel density estimation to do a density estimation in this semantic space. So there are several main steps for semantic density. The first step is that given a prompt and a made response, which we want to evaluate its trustworthiness, we will first sample several reference responses using the same prompt. Then we will evaluate the semantic similarity between the made response and these reference responses and use this information to input into a kernel function. And this kernel function, we are trying to model output distribution in semantic space. And then we can do a density estimation based on this information to calculate the semantic density for a particular position in semantic space. And each particular position is corresponding to one particular response, so that we can use the semantic density at this position as a confidence indicator for this response. So we have run several experiments in our paper to evaluate the performance of semantic density. We implement semantic density to several existing large language models with different benchmarks, and we compare its performance with several state-of-the-art confidence or uncertainty metrics. The way we compare it is that we will use this confidence or uncertainty metric as an indicator to the correctness of the response. So if there is a higher correlation between this confidence score and the correctness of the response, it means the metric is better and more reliable. So based on all experimental comparisons, semantic density performs best among all the compared metrics in almost all the testing cases. And also we have run some experimental results to evaluate the robustness of the semantic density when we reduce the number of reference responses or when we change the sampling strategies for generating the main response. The results turns out that semantic density is still consistently better when we changing these factors. To conclude, semantic density is an accurate, robust, and a general indicator for the trustworthiness of the responses of large language models. For more technical details, please read our full paper, which is published in Europe's. Thank you.